Welcome back, guys. In the previous video we had looked at we are looking at isotopic notation, and we expounded that. We did define an atom as anything. We defined an isotope. We said an isotope is that this is an atom of the same element with the same atomic number but different mass numbers due to different number of neutrons. That's what we did say. And then we also said it is also right to say that this is an atom of the same element with the same number of protons but different number of neutrons. All those definitions are acceptable. We then also did define isotopy, and we did say that isotopy is the existence of an atom of the same element with the same number of protons but different number of neutrons. That's what we call the isotopy, and we looked at the various isotopes, and we will find more isotopes as we proceed. Now, we are looking at ionic formation, but before we look at ionic formation, what is an ion? Now, an ion is a charged particle. An ion is a charged particle that is formed when an atom or a group of chemically combined atoms lose or gain one or more electrons to form a stable ion, to form a stable compound, to form a stable compound. Now, we know from O level that if an element loses electrons, then it becomes positively charged. Then the element that gains these electrons becomes positively charged. That means that we have two different types of ions. That is a positive ion and a negative ion. Now, straight away, let us begin with a positive ion. Positive ion. The other name we use to mean a positive ion, we talk of a cation. Now, when we talk of a cation or a positive ion, we mean that this atom has lost electrons to form an electronic configuration that is stable like that of a noble gas. For example, let us look at formation of a sodium ion. We look at formation of a sodium ion. Now, a sodium has 11 electrons. We say that sodium has 11 electrons. So the electronic configuration of sodium is 281. Now, for sodium to gain for sodium, again say that for sodium to gain a stable electronic configuration like that of a noble gas, like that of a noble gas, it must lose one electron. So if this is my sodium metal, for it to form a sodium ion, then it must lose one electron, such that the electronic configuration is 2 to 8, which is that of a noble gas. And you remember, we always say that noble gases are stable. So this is what would happen for us to form a sodium ion. Let's look at the second ion, maybe. Let's talk of formation of aluminium ion. Now, what do we know about aluminium? Aluminium has 13 electrons. So the electronic configuration, when I say EC, I mean electronic configuration of aluminium is 2, 8 to 3. So for aluminium to form an electronic configuration that is like that of a normal gas, so we say that for aluminium to form an electronic configuration that is like that of a noble gas, like that of a noble gas, comma, it must lose 3 electrons. Must lose 3 electrons. Now, we are going to see how the ion of aluminium behaves. So this is the chemical symbol for aluminium. We are saying it loses 3 electrons. So we say an atom that loses, we say that it becomes positively charged. So that is what happens. So this is the aluminium ion. Now, let us look at the formation of another cation that we know, and it is called ammonium ion. So this is the third one. We look at the formation of ammonium ions. Now we know that ammonium ions are denoted NH4. Now, for formation of ammonium ions, it is not the case as in the formation of aluminium ions that there is loss of electrons. No. This is possible. This is possible because this is possible when the ammonia, or when ammonia is coordinated with the hydrogen ions. This is when this is formed. This is formed when ammonia is coordinated with hydrogen bonds through a dative bond stroke a covalent or a coordinating covalent bond through a coordinate covalent bond. Now, how is this possible? This is possible simply because the nitrogen in ammonia has a lone pair. This is a repetition. Has a lone pair of electrons which it donates to the electron deficient, hydrogen ion. So if we can represent this diagrammatically or by writing a simple equation, we're going to see it here and we realize or we see how ammonium ions are formed. We know that ammonia has 3 hydrogen ions on it. Now we are saying it has lone pairs of electrons. When we add a hydrogen ion here, we form ammonium ions. And when we are representing or writing the ammonium ion, we put an arrow that shows who is donating to who. And this one, we call it a dative bond. So we say that the arrow shows which atom has donated electrons. So that is how ammonium ions are formed, guys. The fourth example, we are going to look at the formation of oxonium ions. We are going to look at the formation of oxonium ions. I think that is example 4. Example 4, we are looking at formation of oxonium ions, and this is how oxonium ions are written. Now, how are oxonium ions formed? Oxonium ions, these are possible because the oxygen in water, has a lone pair of electrons, which it donates to the electron deficient. When I say deficient, I mean a species that is looking for electrons. So the electron deficient hydrogen ion to form a dative bond. Now, if I can sketch my water molecule, we know, or we should know, that the water molecule is V-shaped and has a lone pair of electrons. When we add hydrogen, these form a dative bond such that we end up with something like this, and this is what we are calling the oxonium ions. Therefore, guys, having looked at formation of cations, let's stop here, and in our next video we shall begin from